So I've got a quick revision video here for shapes of molecules. So the first thing I would recommend for any shapes of molecules answer is to draw a simple dot and cross diagram. Now you might have been asked to do this in the first part of the question, but if not, just knock up a quick dot and cross diagram like these, and this is going to help you talk about the main things that need to go into your answer. So the main things are calling this the checklist for shapes of molecules question. The first thing you need to talk about is how many electron pairs, including lone pairs, have you got around that valence shell of the central atom. And just remember, if you've got any multiple bonds in there, they count as one region of electron density. So just treat it as a pair of electrons. Next thing you talk about is how many are bonding pairs, how many are lone pairs. So actually put the numbers into your answer. So the next thing we talk about is repulsion. Will it be equal or not? And if not, why not? So you get equal repulsion when all of the electron pairs are bonding pairs. If you've got any lone pairs in there, you don't get equal repulsion because lone pairs repel more than bonding pairs. And then the final thing is you give the associated shape and angle. So we'll look at those now. So we've got this table here with all the scenarios in. I've got 5 electron pairs in there, even though it's not an OCR, just to complete the table. And you can see down the right hand side I've got some examples. So the first one is 2 electron pairs in the valence shell, and they're both bonding. We get a linear shape and a 180-degree bond angle. And example for that is CO2. 3 bonding pairs, no lone pairs. Example would be BF3. So we've got a trigonal planar shape and a 120-degree bond angle. 2 and 1 now, so we've got a lone pair in there as well as 2 bonding pairs. So we've still got 3 pairs of electrons, but we get a nonlinear shape because we're only really considering the bonds for the shape. The starting angle would be 120, but from the extra repulsion from the lone pair, it comes down to 117.5. So as a general rule of thumb, each lone pair will reduce the bond angle by 2.5 degrees. So we'll look at all the 4s now. So 4 electron pairs, all bonding pairs and no lone pairs. Tetrahedral shape, 109.5 degree bond angle. Example methane. 3 and 1, we get a pyramidal shape and our starting angle is still 109.5, but we're going to take 2.5 off that from the extra repulsion from the lone pair, so we come down to 107. Example of that could be ammonia. 2 and 2, so it's non-linear. Starting angle would be 109.5, but it comes down by 5 degrees from the 2 lone pairs, the extra repulsion, 104.5 degree angle. Example water. So the 5 electron pairs, all bonding pairs I'm just looking at. PF5 is the example. So we have trigonal bipyramidal shape and we have 2 angles in there. We have 120 degrees around the middle and we have 90 degrees from the vertical to the middle. And then 6, all bonding pairs, we get an octahedral shape and all of the angles are 90 degrees. And the example for that would be SF6.